Hi, and welcome to a #BetterHVAC podcast. My name is Ben Reed, and I want to take you on a journey through the chaotic and troubled world of residential HVAC through conversations with industry experts, frontline workers, policymakers, and entrepreneurs. With me today is John Semmelhack from the Comfort Squad. So let's learn a little bit about you, John. What is your background, and how did you get into HVAC?
Okay, so I started out as a home energy rater in 2007, 2008, and quickly realized that among all of the different issues with design and installation of homes, probably the biggest hurdle was with the HVAC systems. And so I like to say that in the US, there's very little in terms of high school or college level of training in home performance and building science. So most of it is on your own through week-long classes, conferences, books, online, and in the
So
field.
very choose your own adventure.
It is very much. Yeah. So I really have been digging into that ever since. Relatively early on, I started doing some HVAC designs for some of our clients, for some of our new construction clients, especially on some passive houses, near passive house custom homes. So that was like 2010, 2011, 2012, and then was started offering that service more and more over the years. And so we were doing design, and then we were doing airflow balancing as far as commissioning goes. So we were not doing installation at the time. So it was just kind of design, commissioning, and then monitoring on some of the systems. And for a while, I always thought, oh, wouldn't it be nice just to take full control over the process and actually do the installations as well? But I'm not an installer. I'm not a HVAC mechanic. So I needed to meet the right like-minded person who was in our area in Central Virginia. And in 2017, 18, I finally met that person in Neil Comparetto and convinced him to start this HVAC home performance contracting journey with me, and we started that in 2019.
And that's when the Comfort Squad was born.
Technically, we were a different name then. We started the contracting company separately from my consulting company, merged them together in 2022, and rebranded as the Comfort Squad. But yeah, our Comparetto Comfort Solutions was the previous name, but we've been doing the same work, essentially, all under the same roof since 2019.
Okay. And that transition from rater to design, were you still working as a rater when you were doing some of that design work?
Yeah, and definitely, and still am. And we're just now phasing out of most of our kind of rating and standalone consulting work in order to focus on HVAC contracting. So we're just doing consulting work in conjunction with HVAC contracting going forward, as opposed to doing consulting as a standalone service for projects where we're not doing contracting work.
And making that decision to take off those kind of mantles of being a rater or even a little bit more of the consulting stuff and then focusing on the contracting, why are you taking that path? Is it more money, like more impact, more work-life balance?
All of the above. I think there's the opportunity to really grow the contracting business, but we and I in particular need to shed some of the rating and consulting workload in order to focus on the contracting, growing the contracting side of the business, especially the existing home end of our business.
And what's the market that you're in right now? Because I've heard that you guys have a bit of a niche. You focus on maybe higher end homes and technical clients. Is that aligned with what you're focused on?
I would say we have three or four kind of typical clients. One is new construction.
Okay.
New construction, custom homes, although also multifamily. But it's not really limited to high performance enclosures at this point. We have slightly above code enclosures all the way up to passive house enclosures and everything in between. And the HVAC systems, of course, are going to be high performance once we get our hands on them. So that's new construction. And then on the existing homes, I think we have 3 different customer types, and there's some overlap there. One is customers who really want improved indoor air quality for various reasons. 2 is customers who have a comfort problem that nobody else has been able to solve. And then 3 is customers who want to electrify their homes, especially their HVAC systems. And sometimes those overlap in the same client. And sometimes those clients are coming from just one particular angle, and they usually wind up getting the other 2 as well, the improved indoor air quality and the better comfort at the same time. Although with every project, we're meeting the client where they are and finding the right overlap between what the client's looking for, what their budget is, what we can provide, and then making sure we're not messing up anything in the house.
And so you said a couple times that you ended, or one of the reasons why you moved out of being a rater is because you honed in on the fact that HVAC was one of the most important things that you wanted to work on. And even now with your business, you guys are focusing a lot more on these high performance HVAC systems. Those are your specialties. Right. What was the aha moment that had you make that transition or had you specialize in that area?
Oh, I don't know if it was a single one, but for home energy raters, it's mostly new construction. So you're seeing a mixture of HVAC system installations on custom homes, but also on more production builder-oriented homes. You're on projects that are getting additional certifications like Energy Star or other green building certifications. You are typically or often reviewing things like the Manual J heating and cooling load calculations, reviewing the Manual D layouts and calculations and Manual S calcs and so on. And so you start to look at the Manual J calculations and see that what has been entered into the software is completely different than what is getting built, for instance. Or maybe it's entered properly, but the equipment that the contractor is proposing is 80% oversized, and the rules require it's to follow Manual S, and it's for our climate, it's 130% is the maximum, or 30% oversized. You see things like that. You see poor duct installation practices, poor duct sealing practices, any number of the various issues that are present in the design and installation of HVAC systems. You see them all the time in new construction, and it was hard to get that stuff fixed. So that's why we started designing them ourselves. Oh, we can actually do this. We can read the books and watch the videos and talk to other folks and actually figure out how to do this. And then I think starting to monitor things, measure, monitor, and really prove the performance of stuff that we worked on to give us the confidence that we were headed in the right direction.
We'll get back to the kind of the monitoring stuff later and the measurement stuff, but like, why don't other HVAC, like you're a rater, all these other contractors that aren't, either they're making mistakes or they aren't following the proper procedure, or maybe even they're falsifying information for like the ACCA, because the ACCA manuals are something that a lot of contractors either don't know exist, or they know it exists, they maybe brush through them, but then they always do the minimum amount required to get the job done. I've heard that there isn't a lot of verification or like third-party validation, like quality assurance on whether or not the contractor has followed those procedures, and even your own path is evidence of that. And so why is it that contractors, they don't do any of that work that is supposed to be mandated in some jurisdictions? And how do you think that would change at any point in the future?
I don't know. It's hard to say. I didn't come up in the industry inside a HVAC contractor, a contracting company. So I don't know. It is really hard to say. I think there's a lot of contractors who focus on servicing equipment and equipment changeouts and don't do a lot of new installations. And then there's others who do more installation work, and there's some that kind of just do new installations and are tied in with bigger home builders and things like that. And I think there's perhaps different mentalities and incentives for all of those different groups.
But you said something interesting, which is I didn't come up in the HVAC. You weren't born
right.
from working in the HVAC field. I've seen that from some other people too, is that there's a lot of bad habits that get developed. Like the fires that birth most HVAC professionals in the residential world almost always result in rules of thumb and maybe a combative disposition and a approach of trying to get a lot of projects done without actually doing them right. But people that have come from other areas, like being a rater, it's very procedure based and it's very quality based, is like where I guess that's what the world in which you were born in.
Yep. Yeah, the manuals are there for a reason. They're extremely useful. And especially even like Manual D, just from a kind of building science standpoint, is quite a good read as a learning tool.
Yeah, but you're a bit of a nerd. I like the majority of contractors aren't going to take that route.
Sure. I think the two big things that are going on is the existing ductwork is installed once. Maybe if it's a new house, it's installed when the house is new, or maybe at some point for a house that didn't have ductwork, ductwork was installed. We're mostly focused on ducted systems, so we can just say the rest of the conversation is all about mostly ducted systems. But so it's installed once and it's baked in the cake at that point, to a large extent. Like there's strong disincentives. There's strong disincentives to touch the duct. It's expensive to fix ductwork. It's a lot of times it's hidden behind drywall, and so there's additional repairs that would have to be made if you start messing with the duct system. So once it's built, that duct system is there for a long time. So all of those mistakes are there for a while, and you can fix, and we deal with this in existing homes all the time. We don't get the opportunity to come in with a clean slate on every single job. Sometimes we do, and we tell the clients, yeah, we love starting with a blank sheet of paper. Then we can get to do everything right. But it's a lot more expensive that way, and the client has to weigh that stuff. So that's one thing, is that the duct systems last a really long time, and it's expensive to make big improvements. Maybe we can come back to there's always improvements that can be made, almost any duct system. But so that's the first thing, is that the duct systems are there. So all of those kind of original mistakes, original sins, if you want to call them, that you're stuck with them for a long time. Or the homeowners they don't know any better. And most contractors they're more used to maybe they don't want to be the one to propose a $20,000 duct makeover to the client when they're worried about just getting the job to replace the equipment that's there.
Yep.
And so I think that's one part. And then I think the second part is probably the kind of the change out market is really just focused on, is the existing equipment maintaining temperature? And if so, then it's the right equipment for the house. And so the easiest, for various reasons, the easiest and most profitable thing to do is to replace and I get that mentality, because it's to make a change to what's there requires more investigation. It takes more time to do the calculations. There's perhaps perceived risk, or on the part of the contractor or on part of the owner, if you're proposing something that's different. If you're proposing downsizing the equipment, or if you're, heaven forbid, proposing to electrify when the client hasn't brought that to you as something that they desire. So those are all perceived risks, and perhaps it's not the easiest path. And most changeouts are relatively urgent. Maybe they're not true emergencies, but a lot of them are pretty close to that. And so there's a combination of something that's pretty urgent in terms of getting the work done, and it's probably for a lot of homeowners, it's maybe an expense that they weren't planning on necessarily. For the landlords, the building owners, they're always trying to keep their expenses to a bare minimum. So they're looking for the lowest price. So there's a lot of pressure to do something fast and something that is inexpensive.
Yeah. And
It's harder to make improvements to us there with those kinds of pressures. Yeah, most of our existing home clients, it's really rare for us to do an emergency change out. It's almost always something that's planned out well in advance. Sometimes it's really old equipment, but it's still planned out.
A lot of times it's education as well. They need to be educated enough to understand what types of investments should be made in their home. They need to have the ability to have that type of financial planning insight as well. So that also is usually a more educated person that does that. And then when they engage with you, they have a lot more trust because those types of people, they're a lot better at delegating and being like, this person probably knows more than me in this particular field. And so if they tell me something that I'm uncomfortable with, I'll still defer to, maybe I'll get a second opinion, but it'll be easier for me to defer to this expert because that's just how I run my life, is that I know that it's important to delegate to people who might know more. Whereas a lot of homeowners,
right.
If you have like you said, somebody who's high performance comes in and says that, hey, we need to downsize your equipment. Now a lot of people, now their anxiety gets triggered and being like, oh,
perhaps,
this is
yep.
that, but it's not the same. Why are they like, this has been working, this amount of tonnage or BTUs has been working for this long. I don't know if I trust you because you're telling me something it's gonna cost more money and then it's gonna work differently. It's just, there's too many unknowns. This is too much.
Right. And you're telling me something that's very different from the other 4 contractors I talked to.
Yeah. With the pressures that most of these changeouts are emergency. And then in that state of anxiety, they will flock to what's comfortable as the same size. So it's really putting the onus on the HVAC professionals over the last decades of saying that, hey, you guys haven't been trained enough. It's really that the market pressures, the demand has been that we are not comfortable with doing things differently. So if you're going to help me in this emergency, I'm going to go with the person that has the lowest price that then makes me the most comfortable, is usually how it ends up. And that's really unfortunate. So I don't think training can fix that. It's not something where you can make all these techs understand the building science to be able to overcome that. It's more of a counseling. That person needs almost therapy during that session instead of a sales pitch or instead of some sort of a building science lecture. They need somebody to be like, okay, let's sit with your emotions. Let's actually integrate some emotional intelligence here. Let's first overcome that hump. And then do we have time to be able to get your system going? Let's take care of that Maslow's hierarchy where you need to have your physical need met, where you can't freeze or you can't cook if there's a heat wave. And so a lot of my exploration is trying to be like, why can't building science practices and high performance HVAC become a lot more common? And it's just because the market forces make it impossible. And it's not really something that can be easily overcome.
Yeah, I think one of the potential opportunities, even with the market pressures that regular HVAC contractors have, is with monitoring systems and the data feeds that are available with some thermostats and some communicating HVAC systems, and being able to say, oh, Mrs. Client, I see you have an Ecobee thermostat. If you have an account, you can allow us to look at the data feed over the last year, and we can see, for instance, that your furnace is 2.5 times oversized, even on the coldest day of the year, which set a 30-year record last year. And they can do the same thing for the summertime performance and see even just looking at the data feed and not knowing that much other than the nameplate values for the equipment, they can get a pretty good idea of what the sizing ought to be. And with a little bit of additional information from some field tests, if there's time to do that, you may be able to go a little bit lower on equipment sizing. If, for instance, you can see, this 2.5 ton AC is actually really only performing slightly under 2 tons of actual cooling performance over this past year. So things like that. So you can wind up derating the nameplate while you're doing that analysis. And that kind of analysis is it's like a 15-minute thing after you get used to doing it, looking at the data feed, picking out some of those cold days, see if there's a repeating pattern of short cycling, and doing the same thing on those hot days. And then if the short cycling, is the humidity also elevated? Oh, there's another good reason to downsize, is for longer run times and better moisture control. And then have that conversation with the client.
So then that's what Comfort Squad does. Is do you do that before a swap out? Is that you institute some sort of a data logging of the home, and then you collect that data and then you make a recommendation?
Yeah, in some cases, anytime we can, yes, we're always using that. For most of our existing homes, we're doing an in-home comfort or home performance consultation so that we can better understand the entire house and not just the HVAC system. If you just have the data feed, then you're just looking at the HVAC system and not really understanding the big picture. And we want to understand, are there additional short-term or long-term opportunities for better air sealing or insulation, better filtration performance, duct improvements, bringing ducts inside conditioned space. We have a market where we have tons of duct systems that are in vented attics or vented unconditioned crawl spaces. So every one of those is an opportunity for further discussion with the client about what's possible, what are the options. And really, we're trying not to assume that the client just wants the lowest price, fastest change. And if they're coming to us, we already have a sense that's probably already the case.
Everybody wants choice.
But we're presenting them with options.
That's interesting that you are already practicing that with monitoring on the sales side. I know a lot of people that once they either install or service a system, then they add monitoring on the maintenance side. So that's more typical.
Right.
So how did you figure out this kind of pre-monitoring to be able to help size and sell a system?
I think a lot of it was from the post-monitoring. Okay. So we were able to see, and a lot of it is still to this day, even many of our systems, and we're some of the most aggressive sizing practitioners in North America, and we still have a lot of systems that are oversized, and we could maybe have gone to the next size down because that's what the monitoring is showing us.
Interesting.
Especially in heating, maybe a little bit less so in cooling, but especially for heating. So that post-monitoring is, okay, if we had this information before this house was built, maybe we're talking about a new construction, if we had this information beforehand, here's what we would have done if we could go back in time. So we're just taking that same idea and applying it to pre-monitoring to an existing home that already has that data feed and already has some equipment, and the client's been living there and they've been operating it how they want it. And if we can get access to that information, it is really it's gold. There's so much that you can learn about how the system is operating. And then, it's in terms of selling that downsize, it's a quieter, more comfortable system. We can have an easier time of adding on really high performance filtration. The equipment is less expensive, so it's easier to afford the better performing equipment, whether it's better performing from a controls, moisture removal, comfort, energy efficiency standpoint. The smaller equipment sizes, it always helps out with that.
What are the essential metrics that you collect in this pre and post monitoring? And then out of those metrics, what are the derivative metrics that you then present to the client during that sizing conversation?
Yeah. So it depends on what kind of device we have access to. So if it's a smart thermostat, Ecobee is the one that we always talk about because it's so easy to get the data feed.
Yeah.
It's just 2 thumbs up, very straightforward, 2 thumbs down. For Google Nest, extremely difficult to get the data. We've had some pretty computer tech savvy folks who do this kind of, not necessarily HVAC stuff, but do this kind of work for their jobs, and they have not been able to get Google Home to spit out the data that we need.
I spent a year.
Anyway, that's a side conversation.
Just quickly, I spent over a year getting access to the Google Nest API when I was at Haven. It was just a absolute nightmare. Not even to develop the app, but it's just the getting the access. They lock it down.
Right.
I concur with that.
Yeah. So if we have ecobee information, so the ecobee is providing indoor temperature and relative humidity, outdoor temperature and relative humidity from a nearby weather station, and then you're seeing runtime, and you're typically seeing runtime on a heat pump system. You're going to see stage 1, stage 2 heat calls. So heat pump call and then supplemental heat. If there's electric resistance heating or if there's a backup furnace, you're going to see that switch over. And that's in 5-minute increments. So that we can basically, we can skip the mild days. We're not really concerned about the mild days. We can go dive into how's the system performing at our ACCA or ASHRAE design temperatures, our 99% and 1% design temperatures. And then how's the system performing outside of those? So even in more extreme conditions. And we can look at the run times on those really cold mornings, on those really hot afternoons, and not just look at one day, but look at multiple days to make sure we're seeing repeatable trends, because you can have situations where, it was super cold on that Christmas Eve, but that client had 20 people in their house generating a whole bunch of heat, and so their system didn't run much. When if there was only the 3 normal people who were there in their household, then it would have been different performance. All right. So just making sure that there's repeating patterns on multiple days. And you can usually get that within a 12-month window or longer that you have with this kind of data. And then in other cases, when we don't have that, we will sometimes install an energy monitor, or sometimes we'll install an ecobee temporarily, like we'll just swap out the customer's thermostat, or we'll install an energy monitor into the electrical panel, and that's going to give us runtime information. So in that case, we're just looking at runtime. We don't necessarily have the indoor temperatures, and we're just going to a weather app to pick out those really cold days and hours of those days, or those really hot July and August days and hours in the afternoon. And then looking at, what's the runtime look like on those days? Are we cycling 20 minutes on, 20 minutes off when it's 100 degrees outside? Okay, yes. Then we can definitely do a downsize on the next equipment. And then the question is, how far do we push it, essentially? If it's running 50 minutes out of the hour on those really hot days, then maybe you can't. If it's running 20 minutes out of an hour, then you definitely can. And then it's a question of doing some calculations to figure out how far you want to go and how safe you feel in pushing that.
How much of this is in line with the Manual J load calculation process, and how much of it is like you've just iterated so many times now that you have forked the process away from what Manual J recommends?
Yeah, so we're often doing this in conjunction with a Manual J calculation, just because a Manual J calculation just doesn't take that much time to do a pretty good one. And so that's more like making ourselves feel comfortable.
And sometimes with you need...
In some cases, yes. Yeah. In some locations, we're not in one of those places for existing homes. But for new construction, certainly. But I think in California, for example, I think that's, if you are pulling a permit for equipment replacement, I think you're supposed to submit the Manual J and a bunch of other stuff, perhaps. And what I hear is that's why HVAC permits have dropped by some huge percent once that rule started.
Yeah, the Title 24.
The contractors found the workarounds.
Yep. They always take the path of least resistance.
But the data feed is really fantastic to see upfront. And we have an interesting one right now, a very old house that actually has a 3-year-old or 2 3-year-old heat pump systems that were mostly installed for cooling, but the contractor chose to put in a heat pump, I think, to have some versatility in terms of their fuel choices. The house also has an oil boiler and old cast iron radiators. And so we're in the middle of trying to get access to the train thermostat data feed so that we can see. We have like one day of anecdotally, it was 30 degrees overnight and the heat pump was keeping up with the 68 degree set point. So we know that the kind of the balance point of the heat pump output versus the house's heat loss is somewhere 30 degrees or lower, but we don't know how much lower yet.
Right.
Until we get that data feed.
Oh man, that's super cool though.
That information is going to influence the conversation in terms of the client wants to electrify. But you can electrify with just electric resistance heat to get that remaining heat, or you could go any number of ways all the way up to a $100,000 ground source heat pump system. And a big difference in upfront cost for the client in between. And we want to be able to provide them with good information about what to expect in terms of the performance of those different options, the approximate energy cost implications, operational cost implications, and then understand the trade-offs, like what could you be doing with that money saved if you don't go with some of these higher price options and put that into your building enclosure, for instance, as another option for how to spend some money.
Yep.
So, but we want to have that data feed first so we can really understand how the house is performing in real life.
It's such a neat trick, this pre-monitoring, or at least pulling historicals from the thermostat to be the easy button for sizing. I'm just surprised that is there anyone else that's doing this? This is the first I've heard of this approach being taken. Are there other contractors, or are there other software providers that do this?
I think there are definitely other contractors starting to do this for sure. It conceivably would be a relatively easy software automation to spit out a recommended equipment size or something like that from the data feed, or make the calculations easier and less labor intensive. Yeah, because now I'm like downloading data into a spreadsheet, figuring out the runtime and making sure it could all be automated. But yeah, at this point, there's millions and millions of smart thermostats that are installed. And there's a growing trend to bigger contractors using things like smart AC, which is basically, this can effectively collect similar information. Haven is able to collect similar information. Haven knows when the system is actually operating in heating or cooling versus just fan on. All of those kinds of devices give that kind of opportunity to have that pre-data feed. And there's nothing better than real world performance to understand how a home is actually working. The Manual J calculation especially on the heating side, but also on the cooling side, has a bunch of conservative assumptions built in that, even when you're following them by the book, yields slightly oversized equipment. And that's fine, and that's correct in most cases, so that you don't wind up undersized on a 90-degree day. Maybe you're undersized on a 105-degree day. But yeah, I'll take the data feed, especially data feed with in-field performance testing of the equipment. I'll take that information over my Manual J calc any day.
Interesting. Now my wheels are spinning because I've got a couple folks that I know who are interested in an open source approach to some HVAC related projects. And I know a guy who, his name is John, who made this open source platform called BStat, which he's got tens of thousands of EcoBees connected to it. And what if a couple of these folks ended up getting together and making a few different library connections to all the various thermostats, and then just unleash that for both people like yourself? You could just pull in this library and connect it to your software. So instead of all these steps, it's just a button, and then you get all the data based on the date range that you want, and it's compatible with multiple platforms out there. Like that'd be pretty cool.
That'd be really cool.
And then companies could build on top of it because it's open source. Now, if somebody wanted to, let's say, license it within their software to maybe Cool Calc or some other one of these, like Quick Model or Conduit, you could like integrate that information to be able to supercharge their load calcs and their design processes and software, instead of it being all this manual work. Because yourself, you're a nerd, you've lived through this process, you prototyped it, you're familiar with it. But for the mass market, if there was an easy button.
Yeah.
So you might have just described that
like
easy
even
button.
I don't have a defined process for doing this necessarily, because it's not like I'm not doing this multiple times each week. we've got, so it's, if I was doing it that many times, then yes, we would be doing that. But we're a pretty small company. We're handling a small number of clients at any given time. So it's still a little bit of a custom process for how I put it together and slice and dice the data.
So what if?
But it can all be standardized and or
And if, let's say, as a lead generation tool, is if there was a step where a customer, just like with BStat, they press a button to connect their thermostat on a web page. It just pulls their data, and then it basically now gives it ends up selling the lead to a contractor in the vicinity who actually wants to use that data to do exactly what it is. So like you could then have more people, like leads coming to you that have already provided this data on a platter, as long as they have a smart thermostat.
Right. Yeah, that would be interesting. And then the clients would have to be obviously have some knowledge of what does that imply now? What does that mean when it's time I'm ready to replace my equipment. I hit this button, and now I'm getting these contractors who are trying to sell me a 2-ton heat pump instead of my 80,000 BTU per hour furnace and 3.5-ton AC.
The communications process was very important to include that in whatever this is. But sorry, I kept us in this hypothetical.
The data feed is gold. I think there's an opportunity there. I hope more and more of the more performance-oriented contractors I suspect they're starting to use this already. And I think we're just internally working on some, especially as I think we're going to get more and more, as you've talked about with Jim Berman and Measure Quick, we'll probably get a lot of dual fuel heat pump systems going forward, which is probably the necessary first step,
unfortunately,
to moving towards heat pumps in a lot of cases. And it's not maybe the best path, but given where we are, it's probably the necessary path. And so then that does make it the best path.
Because it's possible.
We're still going to be doing a lot of the straight heat pump electrifications. But there's certain places where the heat pump performance just isn't quite there, or the customer isn't quite safe enough, or the contractor doesn't, and backup furnace is going to be appropriate. But the data feed is going to show them what the heat pump is actually capable of. As long as they let the heat pump run and not have a mandatory switch over temperature. And then that's going to, if people are actually looking at the data, I guess that's the first big if, then they're going to realize, oh, okay, I could have done this straight electric, and the strip heat would have done 3 or 4% of the BTUs for the whole heating season. And I know an extra cost of this teeny amount. And that would have been a lot easier than doing a heat pump and putting in this condensing furnace. That would have been actually less expensive for the client than the backup furnace that I just installed. So next time I get this chance, maybe I'll just go straight heat pump.
Yeah, the data ends up,
or straight electric, I should say.
Yeah, but the data will make such a big difference in that outcome. So if you can get the data, it almost becomes irresponsible to not use it because of how much it changes the outcomes. Do you shave off like a half ton to a ton, or like you said, you can really change the entire conversation and change all of the outcomes about either the replacement or...
You can even, maybe you have a duct system that is effectively a high static pressure duct system with the equipment that is currently installed on it. And maybe that duct system is already in conditioned space, but maybe it's leaky, but it's in conditioned space at least. And there's no big room comfort problems that you need to solve. So there's no balancing or duct improvements necessarily that need to happen on the kind of branch side, but it's a high static pressure, loud, inefficient from a fan motor perspective, perhaps higher risk of fan motor failure on your air handler or your furnace blower. Downsize that equipment, lower airflow. Now you're moving into a much quieter system that is much more efficient from a fan energy standpoint. And that can literally be like $100 or more a year just in operating costs. We have one example in our portfolio where we reduced fan energy by 90% over the existing system through a combination of reducing the capacity of the equipment to something that was right-sized for the space and making some relatively small duct and filter improvements near the air handler, that stuff is almost always accessible. So between those two things, 90% reduction in fan energy, the client now doesn't know when their system is operating versus when it's off because it's so quiet and it's a variable speed system. We went from on top of all that, we went from a MERV 4 filter to a MERV 13 filter on that system. So we did all of that, made it much more efficient, much more quiet, and added the extra resistance of this high performance filter all at the same time.
That's awesome. It sounds like it's accessible, as in it's accessible for other companies to follow that example. So regarding ductwork, we're going to get to flex duct in a couple of minutes, but those accessible upgrades that you guys do, what are those key takeaways, those small little upgrades that anybody could do that will get those types of repeatable outcomes of that lower static pressure or lower fan energy usage or enhanced equipment lifetime, just something accessible? Because like you said, ductwork is the bones, is stuck in the house. It's very difficult and dirty to try to replace. The accessible upgrades, what are they?
It's in like the equipment room, in the basement, in the equipment closet. It's on the stuff that's the most accessible is typically your return duct and the filter. So those are the two things. The filter is in most cases, is the most important item. Although then you can test that in the field. You can test the pressure drop across the filter to see what the actual pressure drop is, and then start to estimate. Well, yes. There's some assumptions here. We can get to the tools maybe later. But those are the big gains to be had, is basically using a filter that has a lot more surface area of the filter media, which is not just making a bigger filter in terms of the cross-sectional area, but usually a deeper filter. If it's something that's in the duct, then it's a 4-inch or 5-inch deep filter, and a filter that is not matching the nominal opening size of the furnace or air handler. So it's not a 16 by 20, it's not a 20 by 20. It's usually going to be something that's a 20 by 25 or something even bigger to really drive down that pressure drop across the filter. If you have room for it, make it disappear from a pressure drop scenario. Make it so low that it's almost it's rare that you have that much space to do it, but make it, if you can, make it so low that it is just an inconsequential piece of the overall duct resistance equation. And then usually at the same time, in order to make that larger filter fit, you're going to have to make the return duct bigger, which is good. Because if you're making the return duct bigger, you're slowing the air down, and that your key fittings as you come into the air handler, just by slowing the air down, improves the aerodynamic efficiency of the fittings and improves everything. It's often just getting a little bit of separation between the air handler or furnace and the return duct, so that you can have a little bit of I'm drawing this picture on the video. You can have a smoother transition, and then slowing the air down with a bigger duct and right-sized equipment. So usually smaller capacity equipment, so less airflow than your velocity in the duct maybe was 1,000 feet per minute before, and now all of a sudden it's 500 feet per minute. If you cut your velocity in half, your pressure drop across that section goes down by 3/4. So you have exponential improvements. You have relatively small changes in your head wind up having exponential improvements to the system efficiency.
Awesome. Yeah, that's very accessible, and that's very aligned with Nate Adams has his badass drop. It's the same.
Absolutely. Yeah. It's the same stuff.
If trade schools were to teach one thing, to basically be like, hey, all of you new grads or whatever, just do this.
I think everybody, I mean, it's fine for them to teach it. I think it's more important to sell it. And
Incentivize
then,
it, maybe?
because that takes
Is
extra
incentivizing
time.
it possible?
Somehow, maybe. Yeah. I guess being able to sell it and then provide your crews with the time, because it requires extra time to do that work. So if you're trying to do 2 changeouts in a day, you're not doing that work. Now, if we're typically doing a changeout in 2 days. Sometimes more if there's more ductwork involved. That's a different
business model. Yeah.
And you have to be able, it's a different business model, and you have to be able to get paid to do that extra work, of course. But being able to offer that and then having the ability to have a process for your crews to install it that way. Or in our case, that's just what we do on every job. It's just included in the quote. Most of the time, it's not something that is an optional extra, unless there's a base thing that's included in the quote. And then there's some additional things that could be done that are kind of outside our typical.
Back to our conversation about emergency changeouts. That's not really something that they're going to include within an emergency equipment swap, are they?
Yeah, that takes extra time. And if you've got a backlog of customers who all need emergency changeouts, doing that extra day of ductwork doesn't get the next person in line up and running faster.
I hear everybody, whether it's Brian Orr's podcast, Jim, everybody talks about those best practices, but until there's a way to insert that into those emergency swap out situations, it's still going to be something that will only be done haphazardly, I think, which is unfortunate. Before we wrap up here, I just want to quickly touch on the flex duct, because that was how I was introduced to you guys. Is that there was a preconception in the market that flex duct has really high friction and it can't be used for high performance systems. And you guys did a bunch of work to be able to prove that's not the case, I think. And how did that all go down?
But yeah, we're happy to take some credit for it, but now other people have done this before us. It's just, I think it's a recurring theme that every few years or so, someone demonstrates that flex duct is not the devil. And when installed properly, it's a really useful tool. So I think maybe the most recent ones have been Allison Bales has written a bunch of articles and has done presentations and even demonstrations at Building Science Summer Camp in Massachusetts, showing that the pressure drop across a length of properly installed flex duct is nearly identical. It's like this much more than sheet metal. It's tiny. So yeah, with flex duct, it's completely all in how it's installed. If you install it in the way it's really supposed to be installed, which is in straight sections, pulled tight, properly supported, minimal compression, minimal sag, you're going to get very similar performance to sheet metal. And we're at a point with our installation practices that in our manual D calculations, in most cases, we don't differentiate between sheet metal and flex in the calcs, because that's how good the performance of our installed flex
you guys
is.
Are in charge of your you actually do the quality control. Yeah.
We are. We're doing the installation. We're doing the airflow balancing on the tail end. So we know what the systems are actually doing.
Yep. All right. How about we wrap it up there? John, thank you so much for your time today and for all the good work that you're doing for the market. And
thanks, Ben.
I wish you luck on all of these projects. And if I end up finding a group of people that want to create some software for you, maybe we'll pull you in as an advisor to be able to help guide that process.
That would be fun. I think there's a lot of opportunity there for better overall system installations by using that data to install right-sized equipment or closer to right-sized equipment.
Opportunity for better HVAC. Awesome, dude.
That's right.
I will sign off, and thanks again.
All right. Thank you, Ben.